Hi, this is Kenny Lee, and today we're going to talk about pendulums. So let's look at how pendulums work and how can we calculate things like gravity with them. Okay, here we go. Okay, so let's get into pendulums. So pendulums kind of fall into this category where we talk about simple harmonic motion. And that's where it periodically goes back and forth or up and down or left and right. But anyway, the motion repeats over and over and over and over again. And with that, we have to talk about period. Period is the time to complete one of something, whether it's a swing, a rotation, a wave, a bounce like in a spring. Either one, but it's the time to complete one of some cycle. And for a pendulum, the way we calculate period is equal to 2 pi times the square root of L over G. And L is the length of that pendulum. And we measure length from the pivot point to the center of mass of the pendulum bob, as we call it. And so that will be the length. And that's the length I want to give you in these examples. So if our equation is just period is equal to 2 pi square root of L over G, let's look at this question. Does the mass of the bob affect the period of the pendulum? And the answer is, well, no, it doesn't. It's not in the equation. Under small displacements, then this will swing back and forth, and the mass of the pendulum actually has no effect on them. Something that's very heavy, but with the same length, will have the same period. So let's look into some of the problems here. Okay, for this first one, we want to figure out the period of a pendulum that has a length of half a meter. So, period is equal to 2 pi square root of L over G, and G is gravity, and we're going to use 9.8 for that. And so we get 2 pi square root of 0.5 divided by 9.8. So 0.5 divided by 9.8, go ahead and take the square root of that and times it by 2 and times it by pi, which I'm just going to use 3.14. And so the period of that pendulum is 1.42 seconds. And that's all we need. And it's just that right there. So that pendulum should swing from one side over to the other and then back in 1.2 or 1.42 seconds. Or it can swing from the middle out to the end, back over here, and then back to the middle. So it can go out, over, and back. And again, in 1.42 seconds. You just have to have one complete to and fro motion for the period. Well, if we do know the period and we just want to know how long that pendulum needs to be in order to get the period that we want. So in this case, we have a pendulum that we want to have the period to be 2.5 seconds. How long does that pendulum need to be? Well, we start off with the equation again. Period is 2 pi square root of L over G. We know the period is 2.5. That's what we want. 2 pi square root of L, we don't know. And G is 9.8. So the first thing we need to do is square everything. Square the whole thing in order to figure out what's going on. Because we got to get rid of that radical sign there. We got to get rid of that square root. So 2.5 squared. So this becomes 6.25 equals 4, because we got to square this too. Pi squared as well, and we're just left with L over 9.8 because the square and the square root cancel each other out. And so we got 6.25 times 9.8. I'm going to move that over, divide by 4, divide by 3.14 squared, and we get that we need a length of pendulum to be 1.55 meters long in order to have that period. Now this is all on the Earth. What if we were on some other planet or body like the Moon or Mars or something? Can we use it to actually figure out the acceleration due to gravity on that planet? Well, yes, we can. So let's say we got this situation. Some future astronaut lands on a planet, but because of budget cuts, the only thing they have to measure the gravity of that planet is a string with a rock attached to it. In other words, a pendulum. We have a 0.75 meter long pendulum, and the astronaut measures the period to be 2.06 seconds. What is the acceleration due to gravity on that planet? So, we still start off with our basic equation. Period is equal to 2 pi square root of L over G. We know the period is 2.06. 2 pi. We know the length of the period is, or length of the pendulum is 0.75, and we've got to figure out G this time. So again, I'm going to square everything. So 2.06 squared is 4.24 equals 4 pi squared. And then the square gets rid of the square root. And so we got 0.75 over G. And then we just kind of multiply through. Here's a little trick. I call it the super secret metric. Whenever you solve for this, that comes out and we switch and take its place. So G equals 4 pi squared times 0.75 divided by the 4.24. And what we get times 0.75 divided by 4.24, we get that gravity on this new planet is equal to 6.9, let's call it 8 meters per second squared. So we can figure out the acceleration due to gravity on some other body. All right, thank you for tuning in, and check back later and we'll do some more periodic motion. Goodbye.